In this video, I'm going to go through how to calculate a GPU requirement for training, serving, or deploying an LLM. Now, there's been many LLMs that are coming out, like Llama 3.1s, you have the Phi 3.5s, and many other models that are coming out right now. But how do we actually know how much GPU do we actually need in order to train, deploy, or serve a model? Now, I found this really nice blog post where someone was kind enough to post a nice formula, a very simple formula actually, in order to calculate how much GPU do you need. And in this video, I want to go through how this works and also provide you guys with a Google spreadsheet where you can use to just pass in the numbers and calculate how much GPU memory you actually need. By the way, I make similar videos like these on LLMs, machine learning, and other data science tools. So please feel free to subscribe. So for example, over here, I have a Llama 70 billion with 16-bit precision, and it gives a memory requirement of 168 gigabyte of GPU memory that I will need to train and deploy a model like this. Now, let's actually go through the formula. Now, I'm not sure how credible this formula is, but so far through my testing, it seems quite viable and actually quite reliable so far. It's actually giving decent numbers that I can use as a kind of a guiding tool in order to choose which GPU I would need or which model I should probably use to train. So over here, the formula is kind of broken down into 6 main steps. So over here, M stands for the memory in gigabyte. P is the number of parameters of the model. So for a Llama 70 billion, it should be 70. And for 4 bytes, expressing the bytes for use for each parameters, divided by 32. 32 is the 32 bits in each 4 bytes, and then divided by the amount of bits that you'll be loading the model. So let's say you quantize the model and you're loading the model in 8 bits or 4 bits. This should also be accounted, as that can affect the size of the model and the amount of memory you might need in order to deploy it. And then we times it by 1.2. This 1.2 is this extra overhead that you might need to use the GPU to load some other stuff. So typically when you train a model, you have around, or you should have around 10 to 20% in order to load other torch modules in order to train it. Now, they're actually given us a nice calculation. So over here, we're using a Llama 70 billion as an example. So 70 billion times 4 bytes, this is a constant over here, divided by 32, another constant, and then you divide it by 16 bits. Because this model is not quantized, it's going to be 16 bits over here times 1.2, which gives us 168 gigabytes of memory requirement for this specific model. Now that's a lot of memory, and you would probably need around 2 A100 GPUs. So let's say Google Colab, for example, has around 40 gigabytes of A100 GPU. So you would need to quantize it to around 4 bits, if I'm not wrong, in order to train or deploy it. Now, how do we actually use a Google spreadsheet in order to use it? So I've made this nice nifty spreadsheet over here where I made the model name, model size, and bit precision. And what I did was I used this formula over here, and I simply made a quick equals formula where I took the model size, times it by 4, so 4 bytes, divided by 32, which is the constant, and then divided by C2, which is the bit precision, and times by 1.2, which gives us the memory requirement. Now let's build this formula step by step to make it a bit more clearer. So what we will do is we are going to use this parentheses, and then we are going to do 70 or cell B2 times 4 bytes, and then we're going to divide it by 32 divided by bit precision. And after we do that, we are going to do times it by 1.2. And before that, we're going to add some parentheses because of order of operations. There we get the GPU memory requirement. And now we can just apply this to the rest of the models. So over here, this is a Llama 3.1, 8 billion and 16-bit precision. We need around 19.2 gigabyte, which does make sense because when I tried to train a Llama 8 billion on a Google Colab Pro version, I actually did use an A100 GPU. So and it was actually more than sufficient to train it. So that makes sense. Again, I'm not sure how useful, it is quite useful, but I'm not sure how reliable this formula is. But so far, it's been giving us pretty good numbers so far. So this is something that you guys can use as a barometer to see which model you should choose, but also which GPU requirements you might probably need. Now, this formula was inspired from the various mathematics for transformers from Yeluther AI, and it's done by this really smart dude called Sam. So far it seems to be quite reliable. I'm quite curious to know what your thoughts about this are. If you guys are interested, I will provide the spreadsheet link in the description down below. Alright guys, that's a quick video on how to calculate GPU memory for serving LLMs. I hope you found this video insightful. If you guys did, please feel free to subscribe. I make similar videos like these. Alright guys, have a nice day. Bye bye.